Hi to everyone, welcome to NCC channel. My name is Naresh, chemistry lecturer. Today I would like to discuss hybridization and the structure of the molecules. This concept frequently asking in mains, Eamcet, neet. That's why I want to discuss today. The first molecule is BeCl2. BeCl2. In BeCl2 the central atom is beryllium. It belongs to secondary group element. Beryllium belongs to secondary group elements. That means it contains two valence electrons. Two valence electrons. Write like this first. Write like this. Here beryllium is forming two bonds with two chlorine atoms. 1, 2. Beryllium is forming two bonds with two chlorine atoms. Here bond pairs. How many bond pairs? Two bond pairs. And lone pairs 0. There is no lone pairs. Here steric number. What is steric number? The sum of bond pairs plus lone pairs is called steric number. Sum of bond pairs plus lone pairs is called steric number. Here steric number equal to 2 plus 0, 2. If the steric number is 2, the hybridization should be sp. So once consider s power 1, p power 1. So add these two powers, 1 plus 1, that is equal to 2. If the steric number is 2, the hybridization should be sp. And when we observe the structure, central atom is beryllium and it is forming two bonds with the two chlorine atoms. And the bond angle is 180 degrees. The shape is linear shape. In BeCl2, how many bond pairs? There are two bond pairs, lone pair 0, and hybridization is sp. Shape is linear, and the bond angle is 180 degrees. So this molecule belongs to AB2 type. This molecule belongs to AB2 type molecule. That means A is central atom, B2 is two bond pairs. B2 two bond pairs. Next, CO2, carbon dioxide. In carbon dioxide, the central atom is carbon. It belongs to 4th A group. That means it contains 4 valence electrons. Here, carbon is attached to two oxygen atoms. That means every oxygen can form a double bond. Already we know that every oxygen can form double bond. It takes 2 electrons for double bond. How many double bonds are there? 2 double bonds are there. Now bond pairs, consider 2 bond pairs and lone pairs 0. And the steric number 2 plus 0, 2. And the hybridization should be sp. So when we observe the structure, central atom is carbon. It is forming 2 double bonds with 2 oxygen atoms. The bond angle is 180 degrees. And shape is linear. In carbon dioxide molecules, 2 bond pairs and 0 lone pairs. And the hybridization is sp hybridization and the shape is linear. Next, sulfur dioxide. In sulfur dioxide, central atom is sulfur. It belongs to 6th A group and it contains 6 valence electrons. Here sulfur is attached to two oxygen atoms. Every oxygen can form a double bond and the remaining 2 electrons exist as one lone pair. Now bond pairs, how many bond pairs? 2 bond pairs. How many lone pairs? 1 lone pair. Steric number is 2 plus 1, 3. And hybridization sp2. If any molecule has steric number 3, the hybridization should be sp2. S power 1, p power 2, 1 plus 2, that is equal to 3. So when we observe the structure, the central atom is sulfur. It is forming 2 double bonds with 2 oxygen atoms. On central atom it has 1 lone pair. How many lone pairs present on central atom of SO2? 1 lone pair. So how many bond pairs? 2 bond pairs. The structure is bend shape or V shape bend shape or V shape or angular shape. We call it any name. The bond angle is 119 degrees. The bond angle is 119 degrees. Next, boron trifluoride, BF3. Boron trifluoride. In boron trifluoride, the central atom is boron and it belongs to third A group. That means it contains 3 valence electrons. And boron is forming 3 bonds with 3 fluorine atoms. And how many bond pairs? 1, 2, 3, 3 bond pairs. And lone pairs 0. Steric number 3 plus 0 equal to 3. So if the steric number is 3, the hybridization should be sp2. When you observe the structure, central atom is boron and it is forming 3 bonds with the 3 fluorine atoms. The structure is trigonal planar. And the bond angle is 120 degrees. If any molecule has the 3 bond pairs and 0 lone pairs, the shape of the molecule is trigonal planar and the hybridization is sp2. It belongs to AB3 type molecule. Boron trifluoride belongs to AB3 type molecule. SO2 belongs to AB2 type molecule. CO2 belongs to AB2 molecule. SO2 belongs to AB2E molecule. SO2 belongs to AB2E molecule. That means it contains 2 bond pairs and 1 electron pair. 1 electron pair, nothing but 1 lone pair. SO2 contains 2 bond pairs and 1 lone pair or 1 electron pair. Sulfur dioxide, SO3. In sulfur dioxide, the central atom is sulfur and it belongs to 6A group element. That means it contains 6 valence electrons. And the sulfur is attached to 3 oxygen atoms. That means each oxygen can form 1 double bond and each oxygen takes 2 electrons for forming double bond. Here bond pairs. How many bond pairs? How many double bonds are there? 3 double bonds. And lone pair is 0 and the steric number 3 plus 0, 3. If any molecule has steric number 3, the hybridization should be sp2. And when we observe the structure, the central atom is sulfur. It is forming 3 double bonds with 3 oxygen atoms. And the bond angle is 120 degrees. The shape is trigonal planar. In SO3, in sulfur dioxide, bond pairs 3, lone pairs 0. If any molecule has 3 bond pairs and 1 lone pair, the molecule should be in trigonal planar shape and the bond angle is 120 degrees. It belongs to AB3 type molecule. Next, CH4, methane. In methane, the central atom is carbon. It belongs to 4th A group. That means it contains 4 valence electrons. And carbon is forming 4 bonds with 4 hydrogen atoms. And bond pairs. How many bond pairs? There are 4 bond pairs. Lone pair 0 and the steric number 4 plus 0 equal to 4. The hybridization, if the steric number equal to 4, the hybridization should be sp3 hybridization. S power 1, p power 3, 1 plus 3 equal to 4. And when you observe the structure, the central atom is carbon and it is forming 4 bonds with 4 hydrogen atoms. And the bond angle is 109 degrees, 28 minutes or approximately equal to 109.5 degrees. So the shape is tetrahedral. If any molecule has 4 bond pairs and 0 lone pairs, The molecule should be in tetrahedral shape and the bond angle is 109 degrees 28 minutes. And the hybridization is sp3 hybridization. It belongs to AB4 type molecule. It belongs to AB4 type molecule. Next, seventh molecule, ammonia, NH3. In NH3, the central atom is nitrogen. It belongs to 5th A group element. It belongs to 5th A group element. That means it contains 5 valence electrons. 5 valence electrons. And nitrogen is forming 3 bonds with 3 hydrogen atoms, and 2 electrons exist as one lone pair. Now bond pairs. How many bond pairs? 3 bond pairs and lone pairs. How many lone pairs? 1 lone pair. And steric number. What is the steric number? 3 plus 1 equal to 4. Steric number equal to 4. And if any molecule has steric number 4, the hybridization should be sp3 hybridization. And when we observe the structure, central atom is nitrogen and it is forming 3 bonds with 3 hydrogen atoms and 1 lone pair at central atom. And the bond angle is 107 degrees. The structure is pyramidal. If any molecule has 3 bond pairs and 1 lone pair, the molecule should be in pyramidal shape, and the hybridization is sp3 hybridization. In ammonia molecule, how many lone pairs present in central atom? 1 lone pair. How many bond pairs present in central atom? 3 bond pairs. What is the hybridization of ammonia molecule? sp3 hybridization. What is the shape of ammonia molecule? Pyramidal shape. What is the bond angle in ammonia molecule? 107 degrees Celsius. 107 degrees. So like that, it belongs to AB3E type molecule, and that means central atom. It contains 3 bond pairs and 1 electron pair. 3 bond pairs and 1 electron pair. So some more molecules are there. So I will discuss in next video. So if it is useful to you, please like, share and subscribe my channel. Thanks for watching my video.